In this video, we're going to take a look at the Arduino inputs and test them using the SAMrANO as a base platform. To begin with here, I've created a brand new project in Platform.io within VS Code, and we're going to go in and we're going to get rid of these initial functions that are built in because we don't need these. And then next, we're going to start by creating a very simple program. And the program that we're going to create is we're going to create that Hello World program. The reason for this is because as part of the diagnosis and calibration of these sensors, we need to know what the sensor values are reading. And the only way that we can actually know that information is either to have a display on our Samurai robot, which we don't have yet, or to get the information to print out to our computer screen, which is the method that we're going to use. Now, before we go to print, what we need to do is we need to actually set up the commands that are going to use the serial port within our Arduino to bring data back to our PC. So we're going to start in the void setup, and we're going to use the command serial.begin. And what serial begin does is it allows us to set the baud rate. In this case, I'm going to set the baud rate, or the rate with which our serial port communicates, to 19200 because that's a fairly fast communications rate, and it's fairly consistent for what a lot of microcontrollers use nowadays. Now you'll notice a couple things. Serial has to be capitalized so that we can use the hardware serial command. And then the .begin tells us that we're going to set up and configure that serial port during the setup phase of our controller. The next thing we need to do is we need to print text to the screen. And we're going to do that in our loop. So we'll get rid of the comment that was originally there. And to do this, as you may have guessed, we're going to use serial. And we want to use the command print to print text to the screen. And anytime you want to print a variable, you can just write the name of the variable in here. So if our variable was named Bob, we could write in print Bob, and it would print the value of that variable to our screen. But if we want to print text, text is considered what's known as a string. So to do that, we actually have to add quotes around any string that we want to print. So we're going to use the typical hello world. And use the end of line character. And as you can see, this is a very basic program. All we have is we have a serial begin, getting our serial port working, and we've got serial print, hello world, meaning that we should get a printout back to our computer from our controller saying hello world once we download. So let's take a look and go to a view of the robot and our programming software. And let's download this to our controller, or upload rather. Once this uploads, we should see the TX light come on or flash, indicating that data is being transmitted to our PC. In this case, my TX light is on almost solid, which gives me an indication that the data is being sent fairly rapidly and without delay direct to my PC. To test this, or to see the data that's coming to us, we need to go down to this little image of what looks like a plug, which is called the Platform.io serial monitor. And when we click on this, it will open up our serial monitor window, and we should get text printing. But instead of getting readable text, we are getting what seems to be random characters. Now, there's a reason for this. You'll notice up above here, I set my serial begin to 19200. That's the baud rate, or the rate at which the data is coming into the PC. However, my terminal, my Platform I/O serial monitor here, is looking for it to be coming in at 9600 instead of 19200. So we have a baud rate mismatch. This baud rate mismatch is most likely why we're ending up with this weird text displaying on the screen. There's a couple of ways we can fix this though. Number one, we could go in and change this serial begin to 9600, or what I'm going to do is I'm going to go in and reconfigure my Platform I/O, the serial monitor, by going to platformio.ini, and we're going to add the command monitor speed. And type in the baud rate that we want to run at. Now, when we go back and hit that serial monitor window, we should get proper text coming to our screen. And there we go. We've got Hello World literally being spammed to our screen. Now, because I made such a simple program here to begin with, I was able to troubleshoot that the only thing that could be wrong is that baud rate mismatch. Because I had communication with my controller, the text was trying to come in, but it was coming in inaccurate. Now we can see that we've got text just literally flooding into our display, making it almost impossible to read. So what we need to do is we need to add something to slow this down. So we'll go into our void loop and we'll add a small delay. I'm going to add half a second. Re-upload. And you can leave your terminal or your serial monitor window open while you upload. And what it'll do is it'll just reopen that after the upload is complete. This helps us to speed through our diagnostics and our troubleshooting. Now you can see we're getting our text coming in and it's printing it all in one line. In addition, you'll notice that world and hello are smashed together. The reason for this is when the serial print command executes, it executes literally. So there's no space in front of hello, there's no space after world, therefore there's no space between hello and world. The other thing you'll notice here is this is all printing in one continuous line. To make it print to a new line, we can use the print line command, which is just print ln. And every time you have a print ln, it will add a new line or go down one line in your terminal. I've also added that space after hello world. And we're going to say upload. Now you can see our hello world is printing on a new line every single time it executes the command. So at this point, I think we're pretty consistent. We know that we can get information to print out to our computer. So we can get rid of the hello world program, that very basic program, and start working on troubleshooting and bringing in I/O, or inputs in this case, to our display. For now, we're going to close these windows because we don't need those open. And we're going to go back up to our code. Now, all the pins on your Arduino are predefined by this arduino.h, or the Arduino header file. However, the names are not very human readable. So what I want to do is I want to rename the pins in my controller to something that's a little bit easier for us to understand. To maintain good programming practice, I'm going to add a comment to identify what it is that I'm doing at this point. So I'm going to remap the pins. Let's put a space to make it a little more readable. And the way that we do this is we use the define command, which means you use pound or number sign define. And then after we put in define, we give the new name that we want, followed by the pin identifier or the current name that's identified in the Arduino.h. So in this case, I want to use my left sensor. Actually, no, let's use right sensor to begin with. So I'm going to use right sensor for the name. And the right sensor is tied to the A2 pin on our microprocessor. Now I've redefined A2 as RSEN, so I can use that later on in my program. The next thing that we need to do is we need to add some commands to the void setup. This doesn't necessarily need to be done for inputs, because by default your Arduino is going to assume that every pin is an input to the controller unless you tell it otherwise. But for best practice, what we want to do is we want to go in and we want to define the direction of the pin. So in this case, we want to go pin mode, and then you specify the pin name. So now we can use that RSEN instead of A2. Put a comma, and then we tell it that in this case it's going to be an input. And you typically want to do all of your definitions before your serial begin. So I'm going to change this because we don't need to know that this runs once. We know that already. We're going to call this pin directions. And now we can go down into our loop. Now we're going to add some space above our serial print, because what we need to do now is we need to actually do a couple of things. The first thing we need to do is we need to actually take that RSEN value, that analog value coming into our right sensor, and we need to put it into a numerical placeholder, or into a numeric variable within our controller. And the way that we do this is first we have to define that variable that we're going to work with. So in our case, we're going to define int, because we want it to be an integer, and we're going to call this write current, or RCUR, for our write current. Use a assign, and we want to assign the value of an analog read command and what are we going to analog read? We're going to analog read RSEN. End of line. And now we've got that analog read command set up. Now, the thing to keep in mind, you can define these variables in a number of places. If I define a variable within a loop, it only exists in that loop. If I want it to be defined for every loop and every routine that I build for my program, I would put it up above in this area where we are defining our pins, or redefining or remapping our pins. In this case, I only need it to exist within our loop, so I'm going to leave it there. Then we're going to add a serial command. and I'm going to serial print. The reason that I'm doing this is because I want some readable text to know what it is that I'm detecting. Because right now, although I'm just adding the right sensor, in a few minutes here, we're going to add in the left sensor and the center sensor and a few other pins. So we want to be able to know which signal is giving us what reading at what time. So to make sure that this doesn't confuse us, we're going to put in right sensor value with a space. And then down below here, we're going to replace the serial print line with our cur. So what this should do is it should take that right current value and print it after our serial print command. Let's now download or upload. And we've got some problems here. So what is our problem? We forgot that end of line character again. Let's download. Wait for our value to come in after the serial monitor opens up again. We've closed our serial monitor, so let's reopen it. And now we're getting values from our right sensor. To test this, let's grab a piece of paper and put it underneath the right sensor on our robot. Now to verify that we have the correct sensor configured, we can put our paper underneath, and if we have it correctly configured or have defined the right pin, we should see the values change. So we're going from a 1015, paper's underneath just the right sensor, and we've got a 900. If I bring the white paper up, it goes all the way down to 32. So what I can do at this point is I could take this robot, set it on the sumo ring, or set it on the white surface that we're going to be driving on, or on the black surface that we're driving on, and I can set those threshold values or write them down on a piece of paper so that I can use it when I plan my program a little bit later on here. Now we've got one value coming in. Let's add in the definition for some of our other inputs. I've already pre-created these, so I'm going to copy these off of my document here and paste them in. Feel free to pause the video so that you can copy these down. These are the default pins that are configured for the robot. I'm also going to copy in all of my pin modes for my setup routine. Fix the formatting a little bit here. And now we'll go in and we'll add in the values for our left sensor so that we can get two sensors coming in at once. So we'll copy this, paste below. We'll change this from R-cur to L-cur. Change it from right sensor to left sensor. And we can now re-download and verify that we get two sensors coming in. You'll notice as I'm doing this in very small sections. I may have gone in and I may have defined all of my pins all at once. However, the actual code that I'm writing that's running in my robot, I'm doing in small chunks so that I can make sure that things are working properly. So here we go. We've got now right sensor and left sensor coming in. If I put the paper underneath my left sensor, left sensor decreases. If I put it under the right sensor decreases. If I put it under both decreasing and increasing. So now we know we've got those sensors set up. We can go in and we can try out that sharp sensor. I'm not going to use the center sensor because, as you can see on my robot here, I have not soldered in my center sensor. So I'm just going to leave it and ignore it. So let's copy this in. And we're going to do a change of this int, and we're going to call it sharp. Let's call it scur, actually, because we already used sharp up above here for the name. And we're going to do a couple things just to make this a little bit cleaner. I'm going to take all of my initialization of my variables. We're going to move that up. And then we're going to just have all of our print commands in a row here. This way we can create some comments. And let's slow this down to 1 second. And now we've got values coming in. So as you can see right now, my sharp sensor is giving a pretty low value. If I put my hand on my mouse, you can see my hand waving in front. As I move my hand closer and closer to the sensor, we're getting an increased value on our sharp sensor. If I grab a piece of paper, put that paper in, we can start getting that increased value as we see the reflectiveness of that paper coming back to our sensor. So given all of this, we can now go in and we can record the base values for our sensors, write them down on a piece of paper or in a notepad so that we have our base thresholds. And when we come into the next video here, I'm going to show you how to get your outputs to trigger based on an input on your controller. Thanks for watching, and we'll see you in the next one.